Good evening, everyone. Tonight we're going to talk about data analytics, and the goal is to have a very hands-on approach on the workshop. So I'm going to do some talking and some coding first, and then it will be your turn. So what are we going to cover tonight? First, I will do a Python 101, where I'm going to talk a bit about the programming language Python, which is used for data analytics and for data science in general. And here I'm not going to do like a whole 101 on Python because there are many things, just the bare minimum you need to know in terms of vocabulary to understand what's going on tonight. And then we are going to do our first exploratory data analysis on a data set. And so we are going to look at the information, load that with Python, and work as if we were a data scientist. Okay, that will be what I do first. And then when the talk is over, you will be able to connect online to our platform and review the material that we are covering tonight, and also do a challenge on your own. Okay? So what we're going to do tonight is code in something called a Jupyter Notebook. If you're interested into data analytics, maybe you've seen that logo, maybe, or maybe the name. And Jupyter Notebook is something that you can install on your computer, or that you can use online. So for the challenge, after the talk, you're going to use it online. And basically, it looks like this. This is a Jupyter Notebook. In a notebook, what you have is something which looks like a software. So you have a menu, you have some icons. And then here, you have stuff which are called cells. So here, the green one, the highlighted one, is a cell where I can write some code, some Python, and execute the code. So for instance, if I write a very basic Python expression, and I run the code, so I click on run, you see that it's going to evaluate my code and output the return. Okay, so this is what we're going to do tonight. We're going to write code, we're going to run the cell, and then it will display the actual result. Okay? When you do a notebook, you can also switch the cell type, and instead of having code, you will have Markdown. So Markdown is just the name of a fancy documentation format. It's just to write some notes down. So here I can say, let's write our first Markdown cell. And then if I run the cell, what happens is it just gets converted to text, basically. And why is it run? Because if I put some formatting like that, for instance, so I put 2 stars around Markdown word and I run the code, then the code is output in bold. Okay, so Markdown is just a way to write text with some formatting. So for italic, for bold, for code, for links, for images even, just with plain text. Okay, it's not like in Word where you just highlight whatever you want to put in bold and then click on the bold button. So that's a notebook. That's the tool that every data scientist in the world actually use to run their experiments. And what they have is a bunch of cells. Sometimes it's code, sometimes it's documentation. And as they go exploring the data, then they write some notes. Okay, that's what we're going to do. Any question on the notebook? Is that clear? Okay, so let's start with our Python 101. First, we're going to talk about some types, about the built-in types in the language. So what's a type? A type is a way to express the category of a piece of information. So the basic types you need to understand when you deal with data are numeric data, numeric types, and text types. So for the numeric, you have 2 categories in Python, and actually in almost every language. You have integers, and you have floats. For text, you just have string, and there is a third one, which is called Boolean. So let's have a look. Here, I already used some types. What's the type of 2 and 3? Can you guess? Integer. How can I check the type is integer? What command could I run in Python? Can you guess the name of the command we can run to check the type? So it could be dot type, but here it will be type, parenthesis, and what I put inside the parenthesis will be the actual value I want to check. So if I do type 2, I get int, so this is an integer. If I look at the number 3.14, and I run this, what will be the type? Float. So if I run the code, you see, I get float. Okay, this is how you check types. When you have numbers, like in math, you can do basic arithmetic. So you can do plus, you can do minus, you can do times, you can do multiplication and division. That's straightforward. So for instance, if I do this and I run the code, I get the result. So any basic computation you want to do, like in Microsoft Excel, you can do as well with Python. If we look at strings, it gets a bit more interesting. So to write a string, you will start with a quote. Could be a single quote or a double quote. Python doesn't care. And inside the quotes, you will write some text. So for instance, if I type Paris, like that, I just created a string which contains some text. It's one word, but it can be longer, it can be a full sentence. So if I run the code, I don't get anything, it's just a string. And if I check its type, I get str. Okay? So that's our second type, the string. And the third type, which is interesting, is type Boolean. And Boolean is a type which has only two values. Do you know the values of Booleans? So that's the 0 and 1 in the CPU, basically, of the computers, and that's true and false. And so true is written like this, with the capital T. If you don't put the capital T, it doesn't work. It's not recognized by the language. So you get true, and you get false, again with capital F. When you have Booleans, you can start doing Boolean algebra, where you combine true and false. And so, for instance, you can do something like that. So what will be the result of true and false? Sorry, that's just true and false. That's false, okay? True. The only solution for the AND operation to be true is when both operands are true. So true and true will be true, but all the other combinations are false. What about the OR statement? If I do true or false, what is it? It's true as well. And what's the only combination so that OR is actually false? It's false or false. So you have AND, you have OR, and the last operation you can do on Booleans is the NOT, to take the opposite of a Boolean. That's it. Okay, so these are the types that we are interested in when dealing with data. And of course, there are way more types for dates, for lists, for dictionaries, but we are going to stick on that tonight. So whenever you have a piece of data, could be in a CSV, could be in Microsoft Excel or a database, you always have to ask yourself, what's the type? Okay? Is it a integer? Is it a float? Is it a string? Usually those three are the ones you are looking for. So for instance, if we look at the street number, what will be the street number type? So the first ID which comes to mind will be integer, but I would say it depends. For instance, in France, you can say 3 bis or ter, which is like the Latin way of adding. When there are two number 2, there is 2, the official one, plus 2 bis. So then you have to ask yourself, is the bis part of the street number? Maybe not. Maybe it's another column. You see, it's not that easy. Same for the zip code. Zip code, the first intuition is that it's an integer, right? But there are some zip code where you have an A or B, or letter in it. So that's not an integer. What about the annual income of someone? Yeah, it should be a float, okay? Or maybe an integer if we don't count the cents, because for the annual income, maybe we can round, okay? So types are very important when we deal with data. Once you know those three types, basically we're going to talk about variables. Variables are a tool in a programming language to store a piece of information. So here, I wrote a simple line of Python where I create a variable named city. So you can think of it as a box inside my computer on which I write the name, the label city, and in which I'm going to put some information. And the information I put is actually the string Paris. So when you see something like that, the equal sign does not mean equal. It means a sign. It's an assignment. I know that's confusing, but that's not the actual equal sign. So when you have this statement, you should read it from the right to left. And it says I'm going to put the value Paris inside the variable city. So if I do that, let's do it. Let's create a first variable. So city equal Paris. And now if I want to reuse the value of my city, I can just use city and I will get access to the value I stored in the variable. So I can do something like that. For instance, if I want to merge and concatenate that with a sentence, I could say, I live in plus the city. And if I do that and run the code, you see I get a new string which says, I live in Paris. Okay? So when you have a variable, which you can recognize thanks to this syntax, and every time you have something equal a value, you are creating a variable in the memory. Okay? So when you have a variable, basically you're going to be able to call some functions. So what's a function? A function looks a bit like a mathematical function you used to learn back in school. So it's a piece of code that is stored somewhere on the computer that you can call. And for instance, when you install Python, you get some built-in functions out of the box. This page is the Python documentation, version 3.8, which is the latest one. And we have some built-in function that we can use. And so, for instance, we can use the function len. Can you guess what will be the output of the code if I run it, this one? 5. Because I have 5 characters in my string. So let's do it. Len Paris. And this is what I get. If I do len city, what will I get? 5 as well, because city is a variable which contains 5 characters in my string. So if I run this code, I get 5 as well. So a function is something which looks like that. To call a function in the code, you use parentheses, and you put inside the parentheses something called arguments. So here I have one argument, which is passed to my function when I call it. So this is one way of calling functions. Another way is to call a function directly onto an object. So here I create a variable named name, the label is name, and I store Boris inside it. And what I can do is call a method directly on my string. So I don't do capitalize parenthesis name, I do the opposite, which is name dot capitalize. And tonight, the library we're going to use only use this actual syntax, okay? So here, when you read that, you need to understand that this is a string, and I'm calling a method on the string. And so if I do it, so calling a method on the string, so I'm doing, name equal Boris, name dot capitalize. The result I get, what gets returned by the capitalize function, is a new string with a capital B. Okay? So if you want to know what method you can call on a given type, you can do Python str methods. And so Google is actually smart. It shows you a bunch of I mean, the first method you can use, but there's also a link directly to the documentation. Actually, this one is a bit old, it's 2.5. So if we take this one, common string operations, so 3.8, the latest one, yeah. And we should have the method somewhere, yeah, string method. Okay, so you see we just use capitalized, but there are more. Case fold, center, count, encode, end with, etc., etc. So when you use a programming language, you have at your disposal a bunch of tools, which is called a standard library, which contains utilities like that to save time, basically. If you want to capitalize something, instead of coding that yourself, which is not very interesting, you can just use whatever is inside the programming language library. Okay? So this is how you call a method on an object. Sometimes we call also method which needs argument. So here, how many arguments did the capitalized method needed? 0, okay? We just had empty parentheses, but sometimes the method actually needs something. So if I use the end with, I need to pass one argument, and here I'm passing the string s. Can you tell me what will be the output of the code, name.endWith s, if I run it? True or false, or something else? Let's run it. That's true, okay? Because my string last character is actually an s, and that's the goal of this method. You see that you manage to infer the outcome just by the name of the function. We didn't have to go to the documentation to check what the method was doing. That's thanks to a good name, actually. Okay? So usually when the libraries are very used by a lot of people, the naming conventions are good, so just by looking at the code, you can understand what's going on. You don't have to read the whole documentation. That's it for the Python 101. I wanted to do something very short to jump to the interesting part. Any questions so far about that? Don't be shy, okay? You can ask questions. Great. So, before we actually start analyzing data, we need to get some data. So I'm going to talk about data sourcing, which is the art of collecting data from different sources. So what can be the sources? First, the very common source will be a CSV. CSV is something that I'm sure you've seen somewhere in a software or in attachments, or when you go on your bank account, sometimes you can download your financial CSV, etc., etc. So CSV is everywhere in the industry. It's everywhere because it's very simple. It's just a text file that you can open with a text editor or any other software, and that developers can use to plug software together. So CSV is there for a long time. Sometimes the data will be inside a database. Okay, database meaning that there is like a software with a hard drive somewhere in a company storing the data. Could be in the cloud, could be on premise. You don't know. Sometimes the data you're looking for is on a website. It's not on a database. It's on a website that you don't own. A website you go daily to fetch some information. And maybe that website has an API. Do you know what's an API? Who knows what's an API? Raise your hand. Okay. For the other ones, an API is something that the developers of the website you like actually developed something so that programs can interact directly with the website. So an API is an endpoint on the website, not for humans, but for robots, basically. Okay, robots that developers actually build. And also maybe that stuff that you receive in a PDF, in an email, etc. So data is everywhere. And actually, when you look at the data in your company, 80% of it is not tidy and clean in a database. It's just spread out everywhere. So the first job of the data analyst and data scientist in the data team is not to do fancy analysis and modeling and prediction. It's to get the data and clean it and make sure that you can do something with it. That's the bulk of the job. So let's say the data is in a file, or many files, actually. It could be in a structured way. So that could be a CSV, a JSON, or XML. Those are files, file extension that you may know already. It could be inside an unstructured file, so PDF, document, text, okay? Or that could be, the worst case scenario is this one, the binary version, or it's on a file that you need a special software to open. If you have that, basically you can't do a lot with it without paying for that software. Data may be online as well. It could be inside a database, and then to query the data, you need to know the language SQL. SQL is the language that you can use on PostgreSQL, Microsoft SQL Server, MySQL, etc., etc. So it's a standard query language to talk to a database. Now that we have very big repository of data, sometimes a SQL database is not enough, and so we move the data to a cloud, and that will be, for instance, BigQuery if you use Google, but that could be any data warehouse software like Snowflake, for instance. The data may be online behind an API, and then you need to read the documentation of the API. And if there is no API and the data is online, the only solution, the last resort solution, will be something called scraping. Okay, so scraping is a way to simulate a human interaction with a website to fetch information automatically. And actually, that's a whole topic. We are designing a workshop as we speak to teach you about scraping. So that's when you want to work with the data you own or the data you consult every day. Another way to finding data is to look for data sets online. And for that, there's a great tool by Google, which is called Dataset Search. And here you can just use it as if you were doing a Google query, basically. And there is an example, actually, if I click on Boston education data. This is what I get. I get a bunch of data set on the left. So I can click on it, and then I get a link, or sometimes it's a link to download, etc., a zip file. So that's a way to retrieve information. So if you're looking for, for stuff about climate, just type climate, and you will have information about that. Okay? So that will be the source. Another source that we're going to use tonight, actually, is Kaggle. So Kaggle used to be a startup. It's been bought by Google a few years ago. And Kaggle does a lot of things, and one of them is to store and hold data sets that you can browse, basically. And here, if I browse by the most votes, here are the data sets which are the most voted by the community. And you see there are stuff about credit card detection, about heart disease, about the Play Store, the European soccer database, etc., etc. So every time you want to look at a dataset, you just click on it, and you can have a look. Usually there is a preview of the data in here. So here I just have one CSV. It's a fairly simple dataset. Maybe it's big, but at least it's just one file. There are some documentation about it, and there is a download link to get the dataset on your computer. Okay? So Kaggle definitely is something you want to check out. Just to browse and to see what data is out there. There is a lot of open data nowadays, so don't hesitate to have a look. Okay, so now that we know where we can look, let's talk about Pandas. So Pandas is a Python open source library, which has been created by open source maintainers, and it recently turned 1. Before, the latest version of Python is of Pandas is 1.0.1, and a few months ago it was not at version 1, it was 0.20, I think, so a beta version. So that's a very good achievement for them. And Pandas is a way for you to interact with data with Python. So we are going to download Pandas and use it to load datasets and explore the datasets. You can think of Pandas as the Microsoft Excel for Python. Okay, that's a good approximation. So the question would be, why not use Excel? You know, if you are good with Excel, I'm sure you are all better than me with Excel. That's not my tool. You can do a lot of analysis with that tool. But sometimes Pandas is more powerful, so you want to rely on Python. For instance, when you want to handle very large data sets, Microsoft Excel tends to be slow at some point where the file is too big. And sometimes it can crash or even not load the data. With Pandas and Python, you don't have this problem because it's just reading the data as a stream of information from the hard drive. It doesn't try to load the whole thing. When you want to do operations like combining multiple files, say you have 100 CSV files and you want to combine them in a clever way, if you just use Excel, it can be difficult. When you want to interact with APIs or do web scraping, same, that's easier with Python. And once you have the programming language at your hand, you can do whatever you want, basically. So I know that in Microsoft Excel, there is VBA. If you already do a bit of VBA, that's great, because that means that you already know how to program, and you can, at any point, try to learn a new programming language like Python. So, the way we're going to use Pandas will be, again, inside the notebook. I abandoned the book for a few minutes, but we're going to get back to it. And what we're going to do is import Pandas, and then we're going to read a CSV from a file and store this information into a variable. So here, you know that. This syntax where you have something equals something else means I create a variable and store information in it. Okay? And this is just a way to tell Python I want to use Pandas. I'm going to use the read CSV because I'm going to use a data set which is a CSV. But if I didn't have a CSV, let's look at the documentation and the input-output tools from Pandas. And this is all the read function that you can use. You can use CSV, JSON, HTML, even from Microsoft Excel. You can use also SQL, and also you can use BigQuery. So you see it's very versatile. You can use many sources to read information. So that's one way. And the other way is to actually use a writer, meaning that when you have information in Pandas and you want to save it somewhere, you can use the to CSV, to JSON, to Excel, etc., to generate files containing the data you've been gathering, basically. So you can do input and output. I/O means input, output. So here we're going to use the read CSV function. We're going to use a second library in this workshop, which is called Seaborn. And actually, we're going to use a bit of Matplotlib. And so Seaborn is a Python package, open source Python package, to do some visualization. Same, we're going to use it in the notebook to display the data. Not just look at the numbers, but we want to look at graphs to better understand what's happening. Okay, so Pandas, Seaborn, Matplotlib, those are our tools for tonight. First, let's choose a data set to explore. I want to explore with you tonight this data set, which is stored on Kaggle. So the data set name is New York City Airbnb Open Data from 2019. So that's information from the Airbnb website, which contains listings for the city of New York. Okay, so information about the listings. So these are the columns. You have the name of the listing, you have the host name, the neighborhood, you have coordinates, room type, etc., etc. Okay, this is the information I'm going to use. And what I did already is download the CSV. It's 7 megabytes. It's already on my hard drive, and I'm going to use it. So let's start. So let's use Pandas. So to use Pandas, I need to import Pandas like that. This is the conventional way of doing it. And I'm going to read CSV. And here I'm going to pass a file path. So something you don't know yet is the internal structure of my folder, and I can have a look at it with this command. And you see that in the folder I'm working in, I have a data folder. And if I have a look at this data folder, I have a CSV file in it. So this is where my CSV file has been downloaded and prepared. So I'm just going to do pandas.read CSV data / the name of the CSV. And I'm going to store this into a variable called listings data frame. Like that. So here I read the CSV directly from my hard drive. It's contained inside a data folder. I can show it to you if you want. So this is the working directory. This is where I work. And I have the data folder which contains the file CSV. Okay? That's why in the file path I have data. So I have the listing df, and I'm going to use this variable which contains all the data from the CSV. And I'm going to manipulate this one. So what we just created is called a data frame. The data frame is the type which is created from pandas when I use the read CSV. It's a two-dimensional array which has columns and rows, exactly like Excel. Okay? That's the object which is holding the data. So let's have a quick look at our new data frame. And when you want to have a quick look on the data frame, you can use the 4 columns shape columns, the 4 methods shown on the screen. So you have .shape, .columns, .dtypes, and .head and tail. So let's try and use them. Listings df.shape. If I run this cell, this is what I get. I get something called a tuple, which is a Python type, which is a bit like a list. And here we can see that the tuple contains 2 elements. So can you tell me what are those 2 numbers? Number of rows and number of columns. Okay? So you can see that we have almost 50,000 listings in our data set, and we have 16 columns. If we want to have a look at the name of the columns, you can do .columns. If I run this code, this is what I get. So I get the 16 column names, ID, name, host name, etc., etc. I can also look at something called dtypes. And what's dtypes? Can you tell me? Name of the column and the type of the column. So you see some columns are integers, some are strings. Object means string, basically for pandas. And so some are floats. Okay? This is important to look at because sometimes when you read the CSV, pandas cannot understand the type of the data because of the numerical way of writing the information. For instance, if you write a float in the French way, you use a comma. But if you write it in the American way, you use a dot. Okay, so sometimes the CSV has a comma, sometimes it has a dot, and depending on the delimiter, the read CSV may or may not work. So when you read CSV, always do dtypes later and check the type of all your columns to make sure that you loaded the data correctly. Otherwise, you have to go back to the read CSV and pass some information, like, for instance, delimiter equal and maybe say a comma or dot or help pandas to actually read the information. Okay, so our dtype seems to be in order. That's good. And the last stuff that you want to run, the last method you want to run will be head and tail. And so if I run head, this is what I get directly in my notebook. I get a display of the five first rows of my data set. And you see that I didn't have to code anything fancy like a for loop or the print statements or anything. Notebook is integrated with PEMDAS to display the information. So if you did a bit of coding in text editor with the terminal, you are not used to this kind of UI. And actually, that's very nice to have when you are a developer and you go in the data science world. If you never worked in the text editor before, well, just say that's normal, okay? But yeah. Anyway, so here I get the 5 first rows with head, and if I do .tail, can you tell me what I will get? The 5 last rows, okay? So .head is a way to get a quick look at the data set. You can also actually give an argument to the head method, like for instance, head 3, and if you just do head 3, then you get only the first 3 rows. That's it, okay? So if you don't pass any arguments, the default value for the number of rows will be 5. So the first thing we want to do is actually make sure the data is clean. Make sure that we have enough information for all the columns. Maybe we have columns where we have very sparse data. We want to make sure the data is clean. And if it's not, we want to clean it. So one way of checking that the data is clean or not is to run the following code. So you will call isNull.sum, and isNull.sum will tell you for each column how many cells, how many rows have a blank value. So you see that only 16 rows out of the 50,000 don't have a name. Same for the host name. And we can see that the last review, 20% of the data set is empty. So those columns are missing some data. That's important to know if you want to do some statistical analysis on top of them. Otherwise, we have 0 everywhere, which is good. If you do isNull.sum and everything is 0, that's great. So what do we do with that data? First, when you load a CSV, you can ask yourself the question, do I need all the columns? What am I going to do? Here we are going to perform just a simple analysis, but for the sake of the example, I'm going to say I don't need the ID column, the host name column, and the last review. I'm going to say that I don't need the host name, because if I want to do analysis, I don't care the name of the person which is renting the flat on Airbnb. Okay? I just want to look at the price, at the reviews, something which is not bound to the name of the person. So the way to do that will be to use the .drop functions on the data frame, where we're going to give the column names. We're going to say that we are removing stuff in the columns, not in the rows, and we are going to use the in-place true to actually implement the change on the data frame we are looking at. If you don't do the in-place true, you get a copy of the data with the changes, but the original data frame is not changed. So depending on what you want to do, in-place equal true may or may not be required. Here I want to change the data set I'm looking at. So if I run this code and do a head on top of it, you see that my data frame does not have the host name, the ID, or the last review. It's been dropped. Okay? So here I had 16 columns to begin with, and now I only have 13. So .drop is useful, especially when you load a CSV which has hundreds of columns. Okay. Then, if we look at the data quickly, you see in the column reviews per month, for the third row, you have a NaN. Do you know what NaN means? Not a number, okay? So the reviews per month is a float, but some of the rows have the value not a number. And if we want to do computation like the mean, the max, the sum, anything on this column, having not a number in the row will be a problem, because the computation will fail, or we will have to do fancy stuff. So what we can do is clean the data and say in that column, every time we find a not a number, we're going to put a default value. And what could be the default value for the reviews per month column? 0. Okay? That's a fair default value. So we can achieve that with the following code. So let's remove not a number from the reviews per month column. And if you run the code, so listingsdf.fillNA, then passing something which looks fancy but not that much. So this is a list, the stuff with the curly braces, the dictionary, which says that for the column reviews per month, the default value will be 0. That's just a way of writing that, okay? And then we do in place equal true. And having done that, if we look at the head again, then the third row at the number of reviews is no longer not a number, it's now 0. So we successfully managed to replace the missing data with sane default values for our column. Okay? So that's how you clean data. You look at the NA, and you decide maybe that you want to fill with default value, or sometimes you can also use drop NA. There is a drop NA in Pandas to say the rows with missing values should be removed from my data to perform the computation. It all depends on your use case. Yeah?
Are these Pandas functions or Python functions?
All I'm showing since like 15 minutes is Pandas. It's not Python. That's Python language, so that's the syntax, but this is Python, the dictionary with curly braces, and the fillNA is a method you call on the data frame, which is a type that Pandas bring to you. Okay, so now I have a data frame. Let's look at on how we can select columns and select rows. So the way you do that is by using the square brackets notation. So you can say, I want one column, or I want several columns. So look, if I take the second one, this is the same data frame, the listings data frame, but this time I only look at 3 columns. So again, when you have a data frame which has many columns, it may be useful to use this kind of like filtering. So that's how you do it on the columns. If you want to do it on the rows, you're going to use the index, and the index is the bold first column you have on the data frame. Here the index are actually numbers. Sometimes the indexes can be string or dates or anything. Okay, there's no limitation in the data frame. So if I want to say, let's look at the first the first 8 lines, I'm going to write it like that, and this is what I get, the first 8 lines, from 0 to 7. And I can also combine the two notation, like so. So here I selected the first 8 rows plus only 3 columns in my dataset. So I can squeeze and slice the data in any way I want. Okay? That's one way of selecting the information inside the data frame. Okay, something I really like about Pandas is called Boolean indexing. And it goes like that. I'm going to do another cell, Boolean indexing. Okay, and let's look at the listing df, and let's look at the column price. Okay, there's a column price which contains the price of the listings. And let's say I want to do this. Can you tell me what will happen? Yeah, so it's going to compare this 100 to that. But what's the type of the stuff on the left of the lesser than? This. What's this? Yeah, it's actually a series, so that's one column of a data frame. So it's a big list of almost 50,000 numbers. And this is an integer. So we are trying to compare a very big list of integers with just one. So normally, if you do that in regular Python, it doesn't work, okay? Because you can't compare apple and oranges, okay? You have to compare the same type. But here we are using pandas, which means that we get something very, very powerful. So if I run this command, this is what I get. So I get a new series, which is a series is just a column in a data frame, okay? Which contains booleans, which are false, false, true, false, true, false, true. And when is it true?
When the price is lower than 100.
Exactly, when the price at that row is lower than 100. And what can I do with that? Yeah, I can use it to filter the rows in my data set and only keep the ones which have a true. And the way I do that is put everything in the square brackets and put the name of the data frame in front of it. And if I run this code, I only filter the apartments, the listings, which price is below 100. And actually, I can have a look at the shape of this new data frame. And I can tell you that the 20,000 listings are actually cheaper than $100. And just by changing that, say, do we have any listing under $10? I doubt it, but let's check. Yes, we have 11. Don't want to sleep there, I guess, but doing that, you can actually filter the rows because you get a big series of only booleans. Okay? So that's called Boolean indexing. And this is very, very powerful. Again, if you come from a web development background, and you've done some of that, you know there are for loops behind that you have to write, and you have to aggregate the data in a list, and at the end return the list. So here with pandas, it's just one line. That's why it's so powerful, and also it's very fast, very efficient. If you have a data frame with hundreds of millions of lines, you can run that, and you get the result in under a second. Okay. Any question on the basics of pandas? Do you get it? We load the data from the hard drive in the CSV, and then we have something called listing.df, on which we can perform operation, selecting rows, selecting columns, filtering. Okay. So now we can start the actual exploratory data analysis, and the goal will be to ask some questions, some business questions we may have, all of us, on the data, and use pandas and use Seaborn to try and answer those questions. That's the goal, okay? Imagine your boss comes in and has a business question, and your job as a data analyst will be to look at the data and come up with an answer, okay? Great. So, first question. What are the 10 most reviewed listings? I'm going to write down the question so that it will be easy to do. Okay. So question time, and let's start with the first question like that. So let's have a look at the head once again. Which column should I look at to answer the question? So we have number of reviews, which seems to be interesting. And then what do we do with that column? We want to sort it by what? The first one will be the bigger, so descending sort. And then we take the first 10. Okay, that's what we want to do. And actually, as it's something that is done a lot in pandas, there is one method which does it for you. It's called the n-largest. So if you run listingsdf.n-largest, and let's say we want to take the 10 first, on the column number of reviews, those are the 10 lines which have 600 reviews, between 500 and 600 reviews. Okay? Those are the n-largest the 10 largest in terms of reviewed reviews. Okay, first question is answered. Second question. What are the New York neighborhood groups with listings? Once again, let's look at the rows. How do we answer this question? Which column should I look at? So I have neighborhood and neighborhood group. Okay, I have the two of them. Let's look at the first, the neighborhood group. I want to know which neighborhood I have. So if I display the 20 first lines, I'm going to see Brooklyn, Manhattan. Brooklyn, Manhattan, that's it. Are there two? Are there more? How can I do? Yeah, I want to do something like distinct, which is a SQL keyword. But in Pandas, what I do is something called unique. So you want to select the neighborhood group column and call unique on top of it. And this is what you get. You get all the unique values from that column. And you see we have 5 neighborhood groups: Brooklyn, Manhattan, Queens, Staten Island, and the Bronx. Okay? If I do that on some other column, so which column could I use the unique function on? Which one does make sense? So I have neighborhood, which is a categorical column as well. So let's try. Neighborhood. You see that neighborhood is bigger. That's why I have a neighborhood group. It's easier to understand. Unless you are actually a New Yorker and you know all of them. But I'm not. Which other column can you use for that technique? The room type. And yeah, that's it. And maybe also the calculated host listing count, I don't know, or the minimum nights could be used for that, because it's just integer. Anyway, so that's the answer to the question. Third question, which is a follow-up on the previous one. How many listings per neighborhood group? How do I perform this one? So I want to count stuff, but I want to make groups based on neighborhood count and kind of like group them by that column and then count how many listings I have on that group. So to do that, there is something called value count directly on the series. So once again, when we do that, the part I highlighted, the listings df neighborhood group is a series which has the value count method. So if I run that, this is what I get. And the biggest neighborhood group with Airbnb listings, no surprise, is Manhattan. Okay? With Brooklyn close second. When you use that, the interesting part is that the sort is done for you. You see that the first one is like the biggest. I don't have to run a sort behind. That's useful. Okay. So it's almost the same question, but we are not talking about neighborhood group anymore. We are talking about neighborhoods. And we've quickly saw that neighborhoods, when you do the unique, we have lots of them. So here I just want the top 10. If I do the value count, then I get all of them. So I don't want all of them. One way of doing that would be to actually use the value counts, but after the fact, you know that it's ordered, it's sorted, so you can just use head chained after the value counts. So let's try. And I get Williamsburg as the first neighborhood in terms of like number of Airbnb listings in the dataset. Okay? I think you get the gist, okay? Value counts, head, manipulating all of that. Let's try something more interesting. The goal is now to plot a bar chart of the information. And to do that, we can use matplotlib, which is a library that pandas is integrated with. And you see that the only thing I'm adding there is this bit. The dot plot can equal bar. So if I run the same code and I do dot plot can equal bar, this is what I get. Okay? I get a plot of my neighborhoods, which is a bar chart with 10 values. Okay, so actually going from a data frame to the representation in terms of graph is usually very easy with a dot plot. That's one way of doing it. I'm going to show you another way, but this one is the one when you want to do something very quick and dirty. Another way of doing the same graph without going through the hiccups of doing value counts, head, etc., is to use something called a count plot from the Seaborn library. So to use Seaborn, I need to import it like I did for pandas. So import Seaborn as SNS. That's the canonical way of importing Seaborn. And here I'm going to do a count plot of the neighborhood group, actually. And if I run that, this is what I get. Okay, so Seaborn is actually a bit better on the eye, with brighter color and some sane default, whereas matplotlib usually needs some work, needs some more code to actually be a bit better on the eye. Yes? This is a data frame. Yeah, that's a data frame. Anytime you have a data frame, you can do dot plot, and then you will have to do kind equal something. Could be a scatter plot, could be a bar chart, could be a line chart. Depending on your data, the plot may make sense or not. When you have several columns, for instance, it can do 2 bar charts with 2 different colors, or 2 line charts. And actually, it's quite smart on understanding what you want to plot. But if you give a data frame which has 100 columns with numbers, then the graph is unexploitable. You need first to filter the columns you want to show on the graph. And here it's very simple because my data frame is always 1 column. This is 1 column. That's the value count. Okay? Here, Seaborn works a bit differently. Here I'm passing the whole data frame and I'm saying the x-axis will be the neighborhood group. But it could be something else. Which column could I take? Which will make sense for this graph? The room type, for instance. If I use the room type as x, this is what I get. So we have more entire home rather than a private room and shared room. Okay? So the x means this is the column in the data frame I'm going to use on the x-axis to do my count plot. And I'm just counting the listings on every category. Okay? So something which might bother you here is the fact that the count plot, so the bar chart, is not sorted. I don't have Manhattan first, and I don't have Staten Island last. If I want to have it, I need to specify the order in my count plot statement. So I'm going to say, I'm going to look at the index of my value counts to have the actual sort from the value counts. And look, we can have a look. This is what I get when I do that. This is sorted based on the actual occurrences of each neighborhood group. And if I store that into a variable and I use the same code and just passing the order there, then I get the same graph, but the first one will be the one with the most listings. Okay, that's the same graph, it's just the order is a bit different. So what's the influence of neighborhood group on room type? Is there any relationship? I don't know. Let's have a look on the data. So first, we can have a look at what is the actual room type value of space. So we have listing df room type dot unique, and we've seen in our previous graph that we have 3 possible room types in the dataset. So what's the influence on that based on the listing? Meaning that which neighborhood has the most private room or entire home, etc., etc. We want to look at the relationship between the neighborhood group and the room type. And so to do that, we can use a count plot, but this time, instead of just having the X, we're going to have a hue, basically a color, on another column. So that's the same graph as before, but I'm going to use hue in here. Let's have a look at that. So look, I'm just taking this plot and adding hue equal room type, so the column room type, and this is what I get. Okay? So you get a fairly more complex bar chart where you can see based on the neighborhood, the repartition, the distribution of the room types. And you can see that in Manhattan, people tend to list entire homes rather than private room, whereas in Brooklyn, that's the opposite. Okay? So you can put whatever column you want in X, whatever column you want in the hue, and have a look at relationships. Okay? I just took some examples which make sense, but again, we have many columns, and we have the goal of this this part of the data work is to actually be very curious and look at the data. Okay, let's look at some distributions. For now, we just did bar charts, but distribution actually are very interesting. So let's use this plot being a type of plot which is available in Seaborn, and this plot can be done on the price. I want to look at the distribution of prices in the data set. So if I do that, so distribution, so that's listings df. This is the distribution of the prices. So what can you tell me about this graph? So X is the price, and what is Y? Yeah, the percentage of listings at the given price. And actually, it's histograms. We can't really see it, but it's binning the value of prices. It's not just plotting every listing. It's looking at intervals of price value and counting how many listings fall into that interval. So the problem with that is that it's not very readable. And why is not very readable? Yeah, because like some guy listed his apartment for $10,000, so it's pushing the distribution very far. So what should we do? Sorry? Yeah, we kind of like say, let's not look at apartments which are outliers, very, very expensive. Okay, let's try to find where that limit is from the graph. Where would that be? Yeah, 1,000 makes sense. Okay, how can I exclude listings, so rows in my dataset, which are more expensive than $1,000? I just used that 10 minutes ago, right? With the Boolean indexing. Okay, so if I'm doing listings df price more than 1,000, let's count how many of them we have. That's weird. Yeah, no, that's not what I wanted to do. I wanted to select. So here I'm selecting the one which are more expensive. I wanted to count them. Yeah, so I have 200 listings, which is roughly 4% of the whole data set. And actually, if I take 500, yeah, I'm leaving out just 1,000. That was not 4%, it was 0.4. So here, if I do above, if I remove listings which are more expensive than 500 per night, then I will just lose 2% of the data. Okay, we can do that. We don't lose a lot. So I'm going to take the actual opposite, and I'm going to put that into my distplot. So Seaborn has dist with a T. Okay. So this is my distribution, better. Okay? So if I remove the listing which are outliers, so 2% of the data set, then now I get something interesting. So you see that the skew of this distribution is pushed to the left, and the mean is somewhere here. Actually, if I want the mean, I can just do affordable df price dot mean. Okay, so the mean will be $131. Here, in blue, I have bins, and something a bit weird is that when we are trying to look at the interpoled distribution, I have some waves in here. Can you guess why we have this kind of like artifacts? Yeah.
Is it because they want to put price like below 200, below 100?
Yeah, it's like the human psychology. It's like you don't want to put your listing at 200, you want to put it at 195, so that it feels cheaper, even if it's very close. Okay, so that's what we see here. Like kind of like round numbers, and we get the number just below when you put the price on top of it. Okay? This is not a normal distribution, by the way. This is something from a human interaction and psychology in terms of pricing. Okay. So, sorry for that again. Now, if I want to answer the question, what's the distribution of flat prices based on the neighborhood groups? What's your guess? Which neighborhood will be the most expensive? Manhattan. Okay, that's our intuition. So let's check the data to actually answer that. And to do so, we are going to use another kind of plot, which is a violin plot, which is a nice one. And here we are going to say, this is the data frame I want to plot. I want to plot in the x-axis the neighborhood groups, and the y will be the prices. And I will plot the distribution of the price. So 5 distribution will be plotted thanks to this one. So let's run it. And this is what I get. Let's make it a bit bigger. So to do that, we can add this import at the top of our file in here to have access to the underlying matplotlib function below Seaborn. Seaborn is built on top of matplotlib, and I can specify the figure size with this command. So if I run it again, it's bigger. I'm going to hide my header and my toolbar. So you can see the code and the distribution. And so the larger the violin is, the bigger the distribution is at that point. So price in here is the y-axis. Before it was the x-axis. So be careful, we kind of like turn our heads. And you can see that Manhattan is above every group and also very spread out. Whereas the other groups are very concentrated at the bottom. Okay? So the violin chart is symmetrical. You can make it asymmetrical with another option. But here, what you need to look is just half of it, basically. The left half, if you wish. And if you want to compare this to what we have before, you need to turn that 90 degrees in your head to the right, in the clockwise. Thank you. Okay, so that's a violin plot, useful to print distribution based on a category called X. And you can do that with anything, actually. I put the price, which makes sense, but we could use reviews, we could use any numerical data. Okay, so that will be the last question. Last group of questions. So can we plot the listings on a map? And actually this one is interesting because we are going to use a plot in a way which was not designed for, but which makes sense. Look, if we if we look at the affordable information, if I want to plot that on a map, which columns do I use? Latitude and longitude. And on a map, latitude is X or Y? So latitude will be the Y, okay? And the longitude will be the X, okay? So what we're going to do is something called a scatter plot. Scatter plot is a way to put some dots on an XY graph, and we are going to take each listing, and for each listing we are going to draw a dot at the precise coordinates we can see. And that's how we draw a map, actually. Okay, we just take the 50,000 listings, and you take a piece of paper and you put a dot at the XY being the coordinates. And let's see how it looks. So actually, this time we are going to use Matplotlib again. So I'm going to do a scatter plot. The X will be the longitude, the Y will be the latitude. The dot we are going to put on the piece of paper will have a color, and the more expensive it is, the brighter it will be. The less expensive, the darker it will be. And we are going to have a color bar to look at the data. So if you run that, this is what you get. So you see X and Y, longitude and latitude, and these are all the listings, so the 50,000 listings plotted on the XY. And can you see Manhattan? Yeah, in here?
In Central Park.
Yeah, and also, yeah, no listing there. True. So you see like the yellow ones are more concentrated in Manhattan, where it's more expensive. Okay? So you see the visualization is interesting. And as a bonus, I wanted to draw something on top of the Manhattan map, actually. So we're going to use a Wikipedia image, which looks like this. And I want to draw on top of this one. Okay, so that it's a bit better. And this is the code that we need. So we're going to take the PNG from the web. We're going to plot this with the given coordinates that we have in our dataset so that it overlays correctly. And then we're going to plot our scatter plot the same way we did before. And if we do it, this is what we get on top of the map. Okay, so it's easier to have the Hudson River and the Manhattan and the different neighborhoods. Okay? So here, the scatter plot is actually a map, but we also can do scatter plot without latitude and longitude. It's whenever we want to plot X and Y and see a relationship, and usually what we want to find, that's something you're going to have in the challenge because I'm almost done, is a linear relationship between X and Y. Here it doesn't make sense because those are coordinates, but the whole idea of scatter plot is very important. Okay, so just a few topics for you if you want to go further after this talk, before we do the challenge. So first, SQL. SQL is a language that you can start with. If you don't know SQL, it's already very useful in your company. As soon as you get a hold on the database connection, you can already start answering questions. Just with a few SQL queries, you can answer stuff about marketing, about sales, about aggregation over weeks, over months, etc. So here is just a SQL query I took from some of Le Wagon's code. This code is retrieving the alumni information in terms of age to plot the distribution depending on the age of birth when an alumnus enters the Le Wagon. So this is a SQL query. So a topic you should have a look at. Another topic in terms of data sourcing will be API fetching. If you know how to interact with an API, you can already automate part of your job. And here it's not about Python or about a specific programming language. It's about understanding how companies can interact through code and automate a bunch of stuff, and how an API can actually be a competitive advantage. Do you have an idea for those who know APIs of a field, of a sector, or private sector, where API are very important and maybe underdeveloped? Financials, like what? Like banking, for instance? Yeah. So if you take bankings, trading, if you take all of that, banking, the traditional banks are lagging behind in terms of technology. And there are new banks which are coming up, like for instance N26 or Conto or Revolut, these kind of new banks. They are offering APIs and allowing companies and developers to plug banking information into their system to automate part of their job. So providing an API can be a competitive advantage as a company. And that's a topic that you should look into. I'm not going to talk about that because I could talk about hours about that, but look at APIs if you don't know about them. And the last topic, actually we are going to have a workshop very soon about scraping, so keep on posted on the meetup, is web scraping. So whenever you can't talk to an API, you can scrape information directly from a website. That's very useful to retrieve information automatically, instead of yourself going in the browser and checking a bunch of URLs to get information. And finally, there's the big topic, machine learning, which is the next step after what we've done tonight. So tonight we looked at the data in a statical way and looking at graphs, but at some point we want to use this data to do machine learning. Machine learning is a way of doing regressions, classification, clustering. So basically to build a model to do prediction or to try and understand your information. For instance, your customers, you want to put the customers in groups, and knowing which group a customer belongs to can be helpful for marketing, for instance, for segments. So this is what we do after all we've seen tonight, looking at machine learning, and the library you use for machine learning is scikit-learn. And basically, that's it. So what I want you to do now is go to this website, so learn.lewagon.com/welcome. And once you're there, you will be invited with a code to type, and this is the code you need to type. So the page looks like this, learn.lewagon.com/welcome, and you just type AGJBT5, and you will get access to the platform. Once you're in the platform, you will see that you have access to the slides. So all the slides I show to you are there, and you can have a look at them anytime you want. There's a challenge for you to do. It should take you 15 minutes. And then you have a little test to make sure that you understood. And we would like you to give a feedback on the workshop. If you have some time, that would be very helpful. Don't hesitate to, that was the first time we ran it. So if you have anything you want to say, feel free to do it. And you keep access to this platform after the workshop, so feel free in the coming days to just go back to it, and we will put the videos very soon.